All right, Brianna. I'm back. Hear me now?
Yes, sir.
All right. Which one of the papers you want to look at first? APGP, right?
Yeah, maybe the older paper.
You have to tell me which one. I'm going to go random. You never look at them and know which one specifically you want to do.
Should I give you the
Yeah,
questions
yeah,
first?
tell me which year paper.
No, it's not from my paper, it's from my book.
From a book. I prefer work
Yeah.
past paper questions now, because the mind you have to do the questions that have the form coming in the past paper. Them here, because I would want to put up on this, I would want to have it on the screen to just work. What's the beauty about doing it this way?
So the 2013 past paper first, and then go up.
All right. So we're looking at odd months. So on the 2012 one too. There was one on 2012.
I don't remember.
Look at 2012. PGP.
So you're not sharing screen?
I'm not sharing? Really? Good thing I talk. Oh. All right. Okay. All right. APGP. Here's a APGP. 2012. This one. Now we're doing the APGP questions, right? Let's talk a little bit first. So for the AP series, what it is that you're adding same number or same value from term to term. So the first term is A, and that thing that keep adding is called A, is called D. They call it a common difference D. So the second term would be A plus D. The third term would be A plus 2D, and so on. So this gives rise, because if you know this is the second term and this is the third term. When it's a second term, this value here is 1. When it's a third term, this value here is 2, 1 always 1 less. Or you can say second term, you would have added D 1 time. The third term, you would have added D twice. And so the general term for the term number, a particular term N, where N is the number of terms, all right, is A plus N minus 1 times D. That gives it a term number. So we're doing the APGP. You really would like to know what the A is, what the D is, and then you can know what a term is based on the number N. A key thing to remember about APGP is that you see the common difference, it is equal to any term minus the preceding term. So for example, the 15th term minus the 14th term is a common difference. Any term minus the preceding term is a common difference. It's an addition thing. Remember also that the common difference, even though we're working in this formula as if it is positive, it can be positive, it can be negative, it can be a whole, it can be a fraction, it can be any value. Sometimes they even express it algebraically in terms of x or something, right? So that is what gives you what the common difference is. Any term minus the preceding term is the common difference. Yeah.
Where you have the Tn equals A plus N minus 1D.
This is the expression for the term.
Yeah, the N minus 1, the N is the same N as the one at the T.
Yeah, man. So for example, so I'll give you a simple example now. So for example, the 10th term. The 10th term is referred to as T10. It is simply A plus 9D. Because 9 is 1 less than 10.
Okay.
The 15th term is T15. It is simply A plus 14D. But sometimes I don't even bother put that. The 20th term, the 20th term, 20th term is simply A plus 19D. So the term, a particular term, the term itself, the first term plus 19 times that. So what it means enough to get to the 20th term, you'd have added D 19 times to the first term. You get what I'm saying? There's A plus 19D. Can remember I keep adding D. I'm saying the 20th term is reached by adding D 19 times to the first term. That's how we get to the 20th term. Good. All right. So that's an expression for the term. And this is on the formula sheet. That's on the formula sheet in the exam, right? Let me see if this has the formula sheet on it, this paper. If I ever check now. But maybe we'll come up with one of them and show you. The other thing, remember, a term is equal to the D is equal to a term minus a preceding term, right? Other things to remember about AP/GP is how you get the sum to any number of terms, and that also is on a formula sheet. And this is the sum to any number of terms is n over 2 into 2a plus n minus 1 times d. This also is on the formula sheet. So this now is basically where you add up the terms, where you add up all the terms. So if you have n terms and you add up all of them, this is the expression. Another simple way of writing this formula, which is not on the formula sheet, is this. N over 2 into a plus the last term. So if you know the first term and the last term, this can be used as well. Remember, I know the last term would simply also be equal to this expression, a plus n minus 1d. So you see that a here and the a here is where you get the 2a. And then the a n plus n minus 1d is where you get that. So, you know, we can extract the a plus n minus 1d out of this and leave it all the a alone. So when you know the last term, this is a good way to find it as well. If you know the first term and the last term, this tells you the sum of the terms. If it's in an AP, and you don't need the D that time. If you know the first term and the last term, and you know the number of terms, you can find this. Something in terms. But when you're doing the questions, right? The AP/GP question, a lot of the times when they ask you the question, right? Let's go to now. The question a lot of the times will either be asking you for a term, or it might be asking you for the sum of a number of terms. Just that sometimes in asking you for a term, you sometimes use the word sum still, but they're not asking you for a term. So I might ask, for example, like, what is the sum of money in a bank account after 5 years? It all depends on how the AP is set up, because the sum of money in the bank account might actually be a term number, but they might still use the word sum. What is the sum of money? So you have to be careful. So it's a matter of figuring out when they ask you the question, if the question is asking you for a term number, or the question is referring to a term number, or it is referring to a sum of all the terms. Remember now that this is when you're adding up all these terms together. You end up come to that all the way up to the nth term. You end up come to this expression. I can tell you, most AP/GP question, right, lead to simultaneous equations, because they give you information that will allow you to set up two simultaneous equations that you will solve. When is that AP/GP you're solving? When is that not an AP/GP, when is that AP you're doing? You tend to get two linear equations, one half of this and maybe one half of that, for example. You solve them simultaneously, normally by subtracting or adding. You solve them the equation that they get from AP, you solve them normally by subtracting them or by adding them to eliminate what you want. All right. So for example, if you get two equations with the A in them, you might subtract them to eliminate the A, for example. All right. So you normally solve AP simultaneous equations by adding or by subtracting them to eliminate values. But a lot of the times they lead to simultaneous equations. Let's talk about GP a little bit now. So these are the main formula for AP I just showed you. Now remember that the D is equal to a term, like I said, the n plus 1 term minus the nth term. A term minus a term before it gives you the common difference. All right. All right. And you have to remember this formula. It's going to be on the formula sheet still on this one. Maybe on the formula sheet and this one as well. For this total, for the sum of the values. This one won't be there, but it's a good one to know. And this also won't be there. That a term, the difference is a term minus the preceding terms, if you have that. All right. If a question, if I get an AP question, right? And it said to me something like, we said to something like, the 10th term is 15 and the 15th, let's use, and the, let's say the 5th term, let's say it says the 5th term, F-I-F-T-H, so that's 5th, right? The 5th term is 15, and let's say the 10th term is, say them say the 10th term is, that easy figure, that's a 35, for example. Then it means, this means simply that A plus 4D equals 15, you know? And this one means that A plus 9D equals 35. Because this is expression for the 5th term, and they're telling me that it is 15. This is expression for the 10th term, and they're telling me that it is 35. But the thing with AP and GP questions at ADMATS that I've found is that rather than give you questions with just values and that you're working with values and numbers and so on, they tend to try to relate the AP and the GP to some real life situation. And oftentimes they try to relate it to some money transaction. Like somebody have a savings account or somebody starts a saving plan and they're adding the same amount of money each year, or they are applying as interest on the balance in the account each year. Usually some money thing or somebody making down payment on something and then make a original payment and then they pay back at this rate. Just like to relate the AP-GP questions to some real life situation. A lot of the times. Not all the time, because I've seen questions on ADMATS as well where they just give you an AP-GP question with numbers. The thing with the real life one, you always have to interpret stuff. You have to kind of figure out what is the value of the A, what is the D, when it's GP, what is the R? You have to be careful with what is the R. Whereas AP is one where you're adding a value from term to term. The GP is one where you keep multiplying by a ratio. It's a common ratio that you have in the GP. So since we talk about that, let's talk about the GP a little bit now. Right? So for another thing, if the question, let's just do one more line on this question. If the question tells me that, for example, the sum, so for them say the sum to 7 terms, for example, is say 100. Then this statement means that what will be the sum to 7 terms? Remember, I know Sn is n over 2 into 2a plus n minus 1 times d. You know? So this is telling me now that this, when the n equals 7, this is equal to 100. So this now would give me an equation, that this information here, that I just give me, would give me an equation using this. The sum to 7 term, meaning that the n is 7, would be 7 over 2 into 2a plus, remember now, 2a, remember now, the 7 minus 1 is 6, so it has to be 6d. That now is equal to 100. So you see, I get these kinds of equations to solve when I'm doing AP. And those are linear type equations. You solve them by adding and subtracting. That's sort of way you solve them, add and subtract. I can tell you from now, the GP equations that you get, when we do geometric progression, because geometric progression is are expressions formed by multiplying. You're multiplying by a ratio. Those simultaneous equations, you tend to solve them by dividing them. Divide one by the other. You divide one by the other. So for AP, GP, you tend to add the equations or subtract the equations to eliminate or simplify. The GP equations, you tend to divide one by the next, if that is what you get. But I find that the AP, GP questions in advanced nowadays are really very simple. They don't really give you a whole lot of information. We have to end up with 2 and 3 equations to solve and all of that. All right, but let's talk about the GP a little bit. So far, so good?
Yes, sir.
All right, so let's talk about the GP a little bit now. Geometric progression.
So whenever they say something like a number term, that's always the n?
Yeah, n is a number, yeah, m is a term number, yeah, that is the n. When you read the question, as I said, is to figure out what is the a, what is the n, what is the d. You also want to find out if the question is asking you for a term, or the question is asking you for the sum of a number of terms. You have to kind of figure out what the question is asking you, so you know what formula to use and so on, right? You have to look out for those things. Now the GP, the geometric progression now, is one where you keep multiplying. So for the AP is an addition series. The GP you could maybe say is a multiplication series. All right. So the first term is A, and then to this A now, the second term is obtained by multiplying this first term by what we call a common ratio. So the second term is A times R, where R is a common ratio. So to go from term to term, you are now multiplying by a value, which is called a common ratio in the GP. The next term is going to be AR squared. And this carries down to the nth term of a GP. And if you look again, when the power here is 1, you're at your second term. When the power here is 2, you're at your third term. So it becomes AR to the n minus 1. When the term number is 3, the power is 1 less, as you could see here. When the term number was 2, the power is 1 less, because the power up here was just a 1, and so on. So that is a trend. So this becomes your term number. This is your term number, the expression for the term. I think they give this on the formula sheet as well. The term of a GP. A is the first term, R is a common ratio, N is the term number or the number of terms. All right? N is the number of terms or the term number. Like the 10th term is A times R to the 9th. So you can say, for example, the 10th term is AR to the 9th power. The 5th term is simply AR to the 4th power. Whatever the term number is, you put 1 less up there so on the power. All right? Simple as that. But this is the formula for it. AR to the n minus 1 for the term. For the GP, so whereas for the AP, you subtract to get the difference. A term minus a preceding term, right? For the GP, the common ratio is a term divided by the preceding term. That's why I get the ratio. So for example, the ratio equal the 10th term divided by the 9th term. Which kind of makes sense. Because remember, you have to multiply the 9th term by the R to get the 10th term. Right? That's why it kind of makes sense. So a term divided by the preceding term gives you that common ratio. All right? Now, another thing about GP is the sum. So again, you're going to get that on the formula sheet. So the sum to any number of terms is a formula that says it is A into 1 minus R to the N. Notice now that R to the N minus 1, R to the N in the formula, over 1 minus R. When the R is greater than 1, you can turn these around and instead write it as A into R to the N minus 1 over R minus 1. We're kind of safe to stick with this one. I'm going to tell you a reason why I kind of safe to stick with that one. Because this is a sum to any number of terms. Right? So the sum to n to 10, you're going to put 10 right there, so. And common ratio and so on. Right? Now there's a special thing that we said about a GP. A GP can be convergent. Can be convergent. When it is convergent, that sum to infinity, that sum to n terms. Oh, first, when it's convergent, right? The common ratio is a fraction. It is less than 1, but greater than -1. It's a fraction. The common ratio is a fraction, like half, not 3 over 2, because 3 over 2 bigger than 1. 2/3, -1/4. All of these, 1/8, -2/5. All those fraction value that we work out with 0 point something, 0 point some number, or -0 point some number. All the common ratio would, as a decimal, will become that. Has what we call a sum to infinity. It is convergent and converges to a sum to infinity when the R is between -1 and 1. Another way to write this is to say the value of R, the modulus of R, the size of R is less than 1, meaning that the R is a fraction value, whether positive or negative. That's another way of writing this. And when that happens, the sum to n terms converges to what we call a sum to infinity. That's how I write it, but this is a symbol for it. A sum to infinity, and they actually use that word, sum to infinity. Which is now equal to, I'm going to put this up here, so. This and this is the same thing. This is another way of writing that thing. And that sum to infinity here becomes
That's a
equal
plus
to,
or a R, sir?
where? This is the R, man. R. I'm talking about the common ratio. The common ratio, R.
Okay.
The convergence of it depends on the R. R has to be a fraction. I'm going to explain to you why just now. So, but what this sum goes to, and I give you this formula in the formula sheet, you know. Because a sum to infinity, which becomes equal to A over 1 minus R. Now, why is that? Because see this R to the N, it becomes 0 when N becomes very, very, very large. Let me give you an example now. So it's basically saying when the number of terms get very, very large, comes to infinity, this sum in this formula tends towards this. It goes towards that value. The sum to N converges to this instead. Now, why is that? Let me show you why. When the R is a fraction, you can test it for yourself. Like, for example, 0.5 raised to the power 80. This can almost be 0. Because a fraction multiplied by itself multiple times is getting smaller and smaller. This is approximately 0. I can show it on the calculator. So when you raise a fraction to a very high power, it becomes very, very small. It tends to 0. Right? So that is what is happening. So sit here, can show you on the calculator that you're going to get a very small value if I raise 0.5 to the power 80. You don't even go to the power 80. Raise to the power 80. See that? You get something to the 10 to the negative 20. Maybe it's a smaller value. Let me use raise to the power 20. See, still get a very small number. Let me go to the power 10. So that 0.00 something. So it goes towards, the more I go, it gets smaller and smaller. 12, 13. See, it getting smaller and smaller. 14. See, it gone into 10 to the minus power now. So the more terms you have, when you have a negative power, the sum of the values tending towards a sum to infinity, which is equal to this, because the r to the n expression here approaches 0. And you're left with 8 times 1 over 1 minus r, which is what we have here. So. But this only happens when your r is a fraction, right? This is when it only happens, when the r is a fraction value. That's the only time it happens. R is a fraction. And it's only a GP that can converge. It's an AP. An AP is what we call divergent. It does not converge. An AP is divergent. All of them divergent. Them don't tend to know one value. The sum does not tend to any one value. So all of the APs are divergent. APs are divergent series. Is divergent. A divergent one is not one that is not convergent. Means the sum don't tend towards no one value. But a GP can be divergent, but it can be convergent as well. So if the R, for example, equal 5, then the GP becomes divergent. The sum is not approaching any one value. The sum actually goes towards a value of infinity itself. Get me? But when the R is a fraction, this thing here, so as I've said, becomes 0, and the sum tends towards this value. Something that you have to know. All right. So those are some of the key things you're gonna buck up in a GP. Now make sure to tell you one more thing now that you have to look out for as well. For example, remember, you know, the R is something that you're multiplying by. Now sometimes what they'll do, they'll express the R as a percentage. Sometimes they'll express the R as a percentage. Now what is now? Remember, you have to multiply by R. So to go from value to value, you multiply the original value by the ratio, right? Listen good now. If something is increasing, if a value is increasing by say 5% from term to term, then the ratio is really 1.05. Because 5% is 5% is 0.05, you know. But the new value is going to be 105%, going to be the new value. So to get the new value, if you multiply the original value by 105%, and 105% is 1.05. So if something is increasing from value to value by 5%, like for example, let's say you have some money in the bank, and they like to do this in questions. You have some money invested in the bank, you have an investment in the bank, and the interest rate is 5% per annum. And that 5% is applied to the value that is in the bank at any time. Then it's going to become a geometric progression. The amount of money in the bank is going to form a geometric progression. So the first year, the amount of money in the bank is $100 when you start. The new value is going to be $100 times, if you increase it by 5%, it becomes times 105%. That's going to be the new value. And remember now, 105% is 1.05. If you increase in some by 5%, it is a geometric progression of 1.05 common ratio. Then this is the amount in the bank now, in that year. you're gonna apply 5% interest on that again. So then you're gonna have to apply another 1.5% to this. So you're gonna get now $100. That's value in the bank now, times 1.05 squared. So it work. So this is now the value in the bank. You get me? So this is the value in the bank, So you can't say you're adding these values, This is the value in the bank now after 2 years. And this is where you start with. This is after 1 year. That's after 2 years. You get me? So this is when you start. And that's another thing with AP-GP questions with the years. Sometimes the first term is when you start. So that is like year 0 when you start. Year 0. The second term is actually after 1 year. It's really after 1 year that, the second term corresponds to 1 year later. The third term corresponds to 2 years later. That is year 2. Right? So you have to be careful when you're dealing with years. Remember, you start years, so you start at that point. Then 1 year later, you're just at your second term after 1 year. You get me? So when you're doing these things in years, remember, they don't call this, even though this is your first term, it corresponds to year 0 when you start. Your second term corresponds to year 1. So you find that the year number is tracking 1 behind the term number. The year number is tracking 1 behind the term number. Because this will be the first term, this will be the second term, this will be the third term.
Oh, so it's like the P equals 1, what is it, minus or plus R over 100 squared?
Where you talk about?
Like how you said that it's the rate, the 1.05 squared.
Yeah,
there's a formula for, I think it's, what you call it?
Compound interest.
Yeah.
Compound interest is talking about. Yeah, but you have to kind of be careful, right?
Mm.
Yeah, it's a compound interest formula, but you have to kind of be careful. You have to read the question and see what the conditions they put on it. You don't want to go in there and be just dropping a compound interest formula on what you're doing. You have to make sure that it is aligned with the particular question. There are a lot of spin-offs from these things. Just that compound interest is one of them, but the compound interest is basically under particular conditions. So it can be that you're doing a GP question where the conditions are not fully aligned with the conditions of compound interest. More than likely it will be, right? More than likely it will be, but we still have to be careful. But I don't think this the exam syllabus set up for you to apply like a compound interest formula. I mean, it's okay to have advanced, and if you recognize that you're doing a question and it's just that you're not gonna get every question that requires you to use a compound interest formula, because it can be also, well, I guess compound interest, and if the interest rate, if it's something decreasing, because it could be that something is decreasing by 5%. So if something is decreasing by 5%, then the ratio becomes 95%, which is 0.95. So if it's a case where the value is decreasing by 5%, then your common ratio would be 0.95, because the new value would be 95% of the first value. Remember, you're looking for what value you need to multiply the original value by to get the new value. That's what the common ratio is. What do I multiply a value by to get what the new value is? I'm multiplying. What do I multiply it by? That's what the common ratio is. So a lot of time when they give you percentages, you write them as a decimal. So then give me, so something increased by 5%, as I said, then my common ratio is 1.05. If something is decreasing by 5%, then my common ratio is 0.95. Because 95% that is left. Because to get what the new value is, I have to multiply the original value by 95%. But if 5% has gone from it. All right. So I think that what I've just gone through kind of give you a little bit of background on the topic, like just off the top of my head, I just did that. So I guess if there's anything else, it will come out in questions. But these are the main formulae, and I think the thing with the GPU, and they actually give a 3 formula on the exam paper. Right, this, and this. For this one, remember, I can switch around these and write it as, and it might be that way, a into r to the n minus 1 over r minus 1. All right, so this one can be written like that as well. All right, so just a matter of looking at the past paper and see which one I give. But if I were you, I would work with this one, because remember that this is the one that leads to the sum to infinity. All right, the one that leads to the sum to infinity is that one. So I tend to just stick to that one. I tend to use this one right here if the r is greater than 1. And I tend to use this one if the r is like a fraction. You get me? That's what it normally works. But this one will work whether it's a fraction or not, still a number. But I'm just telling you what the practice is. All right, so that was a little bit of background on the GP. All right. Yeah. So remember what I was telling you? Give like an example now, right? About how you would end up with simultaneous equation that you have to divide. All right, that you have to divide. So suppose them tell me that the 10th term of a GP is, let's use the same 15. And let's tell me say I make this be the 5th term or the 4th term. And let's tell me say the 6th term of the GP is, might be 25, for example. Now what this means is that this one, the 4th term, is AR cubed. AR to the n minus 1. So it is AR cubed. That will be equal to 15. And then this one now is the 6th term. So it will be AR to the 5th power. AR to the 5th power. Because AR to the n minus 1. So it's AR to the 5th power. That will be equal to this 25. So because these are two equations that are derived through a multiplication process, because that's what the AR is, you know. You keep multiplying by the R. To solve these two simultaneously, it makes sense to divide them. When I divide, for example, this side by this side, I will eliminate the A. So I will divide these two to solve them simultaneously. So divide, because it is derived from multiplying values. Right? So it's a multiplying series. So you divide to solve them simultaneously. AP is like an addition series. So you add or subtract equations to solve them. So this one I would divide. So I'll put this one over this one. So I'll put the left side of this over the left side of this. The A's would cancel. I will get R to the 5th over R cubed. So I will get, let me write it out. AR to the 5th. AR to the 5th over AR cubed equal this 25 over the 15 that this is. 15. And you realize now that these cancel, right? So this A is cancel. Then R to the 5th over R to the cube becomes R squared. So this becomes R squared. And then this was simplified down to what? 5 over 3. R squared equals 5 over 3. And then now, the R will be equal to the square root of the 5 over the 3. And you can have a plus or minus. And what would happen is that they would maybe give you some information to tell you whether you use the plus or the minus. But the key thing I'm trying to show you is that the simultaneous equation that you get from GP, you tend to solve them simultaneously by dividing one by the next. All right, so I think I did not know that I would have done that little quick summary off the top of my head, but that's how it is. So let us go now and see how the questions are done. So it's basically just know say, you know, you have some formula and they can use the formula then when you're trying to decipher what is your A, what is your B, what is your A, what is your R, what is your N, what is your D. Whether there's an AP or a GP. Sometimes I give you information and don't tell you which one I see is it is. You have to figure out whether there's an AP or a GP. Once it is one where they are adding or subtracting the same value from term to term, subtracting or adding, you know, it's an AP. If it is one where you're multiplying by the same value from term to term, then it's a GP. Oh, there are questions that will ask you to prove that a series is a GP or prove that a series is an AP. Most of GP. All you need to do is show that it has a common ratio. We show that it has a common ratio right through by showing that the term divided by the preceding term is the same throughout. Or another way you can do it, you can show that the series that they give you can be expressed in the form A plus AR plus AR squared plus AR cubed, and so on. Show that the term can be written like this. But most times I just show that it has a common ratio by dividing a term divided by a preceding term throughout and show that that common ratio exists. I'm sure once we start to work, we'll see a couple examples like that. All right, let's look at this one though. So this one says, a customer repays a loan monthly by increasing the payment each month by X dollars. So they are increasing the payment by X dollars. If the customer paid $50 in the fifth month, so this is the AP, you know. I say you're increasing a value that you're putting. So I can start out with a value, and the amount, the payment is increasing by the same amount. So these are my payments. So these are my payments. So I'm making some payments, for example, right? But my first payment was, say, $100. Then my next payment is $110. Then my next payment is $120. Then my next payment is $130. Then my next payment is $140. So this is a geometric, this is an AP series because my terms, the amount that I'm paying is increasing by a same amount, by $10. So the values, the payments is in the form of an AP. That's what does that mean? Because you're increasing the payments by the same amount each time. All right, this says now, if he repaid $50 in the fifth month, I'm going to take that to be the first term. He paid $50 in the fifth month. That means that the fifth term is 50, right? So I can actually maybe do it right here. It means that the fifth term is 50 now. What is the fifth term? The fifth term is A plus 4D. So I'm going to say that A plus 4D, because I realize it's that GP first. I realize that AP because you're increasing by the same amount in each month. Customer repays a loan by increasing the payment each month by X. This is like a common difference, but you don't have to worry about that. It works out itself. I'm just going to call my common difference these just to see. Right? So the fifth payment is $50. So that's A plus 4D equals 50. I don't have to put the dollar sign on it. The ninth payment, he pays $70 in the ninth month. That's the ninth payment. The ninth payment is A plus 8D. D is the amount that you're increasing. I could have put X right here now. Instead of D, I could have placed X right here, because X is the amount that is increasing by the difference. Is increasing by that difference every time. But I can still just call it D to work out itself. This equal how much? $70. Those are my two equations to work out my A and my D now. It says, calculate the total amount of money we paid at the end of 24 months. You know what this is asking for? The total amount of money we paid is the sum of all the payments. The sum of all the payments of the 24. So this is asking you for the sum to 24 terms. That's what this is asking you. The sum to 24 terms. Write it down here. So sum to 24 terms, which will be 24 over 2 into 2a plus n minus 1 times d. You have to go work out the a and the d from the two equations here. And since they are AP equations, you solve them by subtracting. See, subtract. You don't need to divide. Subtract. I'm going to subtract them. The bigger one minus the smaller one. Subtract. So when I subtract them, I'm doing the second one minus the first one. So A minus A gone. 8D minus 4D give me 4D. 70 minus 50 give me 20 on the side here. So it means that the D equals 5. The amount that I'm increasing by is 5. Next, I need to find the A. I can take the 5 and plug it in as so. So the A equals 30. You can see it because this becomes 4 times 5 is 20. 20 come over here and subtract from the 50, give me 30. So the A equals 30. And my money in it, but I'm just leaving out the dollar sign for the time being. So the original amount that he paid was $30 and he's increasing his payment by $5 each month. Now I want to know what the total payment is. It's the sum of all the terms. This was the first payment, you know. The second payment would have been 35. The third payment would have been 40. Next payment would have been 45. Next payment would have been 50 and so on. I want the sum of all the payments. So I'm trying to work this out. So it becomes equal to, and it's right here. 24 over 2 is 12 into 2 times A. The A is 30. 2 times A is 30. Plus n minus 1, it becomes 23. Remember, 24 minus 1 is 23. So I put 23 times the common difference is 5. Whatever this work out to now, put the dollar sign in front, it's I'm done. Understand that?
Yes, sir.
Go do that? Simple as
Yes,
that.
sir.
All right. So that was a straightforward one. We could look at 2030. Let's work through them, right? We could look at 2030. 2030. Let's see. 2013. See there, advanced 2013. So I just did a question on it. That's why it's there on the screen. So we're in the class and see the form. This one has a formula here, you know. So see here the formula that I get in. Getting this one for the term number. That's for the nth term. We have to remember that. Just remember, for example, the 9th term is A plus AD. So 9th term. So if the 9th term is 20, the 9th term is 20, then this thing equals 20. That is it. It's not complicated. And then this now is the formula for the sum to any number of terms. See there? Remember, a good formula that is not shown here is n over 2 into A plus L. If you know the first term and the last term, this sum can be that as well. It's a good one to know if you know the first term and the last term. That one you don't know, you don't need the D. Then now the formula for GP now. See, this is the term number. Remember now, the 9th term, for example, again, if a GP just AR to the 8th power. Not complicated. Just one less than that. One that the 9 minus 1 is 8. We don't have to put 9 minus 1. We just write 8. This is a sum, as I told you. See? I say I tell you that I put it this way around, this way, where I prefer it this way. if the 1 minus r to the n over 1 minus r, so I told you, they'll give it this way on a formula sheet. But this is also good. I'm going to put it here so I know here. So this is also good if you write it like this. A into 1 minus r to the n over 1 minus r. But this is the one that leads to this sum to infinity. When this becomes 0, because the r is a fraction. So then put it here. So you get the sum to infinity provided that the r is between -1 and 1. That's what I showed you earlier. So all those things I showed you to be on the formula sheet, except this, and just that this now is written this way instead of this way. I prefer it this way because, as I said, this way leads to that. All right, and I'm telling the conditions when it converges. It only has a sum to infinity when this happens. So you have to know that as well. You have to know that as well. Because they can put, for example, on the multiple choice, that the R for a GP is, for example, 3/8. You have to know that this therefore have a sum to infinity. Because 3/8 is a fraction. Once the R can be written by a decimal, 0 point something as a decimal, 0 point any number. If I am 0.999, it have a sum to infinity. No matter how close it gets to 1, still have a sum to infinity. Right? And again, if the R equal 1, you don't have a GP. Remember that too as well. Right? But the R equals 1. If the R equals 1, look at it now. Makes sense now. If the R is equal to 1, then all the terms are the same. A. You don't have a GP. Because the GP presumes that the values are not the same. If the R equals 1, you don't have a GP. You get me? Because you multiply this by 1, you get the same, you multiply that by 1. So you don't really have a GP if the R equals 1. All right, so that is another thing to note. All right, so let's continue down here. If there are any questions on it. Let's see. Up here. All right, so on here, look at this one now. They said, find the sum to infinity. Look now, find the sum to infinity of this series. And I give a note. They said, no, this series can be written as the sum of 2 geometric series. So there are 2 geometric series in that. So if you look at them and see what those 2 geometric series are, and remember the sum to infinity as a form a over 1 minus r. And they're saying this has 2 sums in it. 2 geometric series, so it has 2 sums in it. So let's look at it now. So these look like the ones that go together. Right? These go together. Because them have thing on the numerator and these go together. So there are 2 series in there. Let's look at the 2 series. I'm gonna pull them out. So it looks like it's a series in red. I'll write them under here. Series in red would have been a quarter plus 1/4 cubed and so on, right? And the series in blue would be now 2/4 squared is the first term plus 2/4 to the 4th power and so on. So for the first one, what is the A? One right what them is now. What is the A in the first one? The A is just 1/4. What is the R? The R for the first one, how do you go from this to this? Multiply by 1/4 squared. Remember, the ratio is what you multiply this by to get this, you know. Or you can say this divided by this. But you can also look at it and say, what do I multiply this by to get this? 1/4 squared, because I go from a 4 on a here to a 4 cubed. So I multiply by 1/4 squared. So the R, and this is 1/4 squared. All right. So once I have those, I can find the sum to infinity of this one. So my sum to infinity of this one, let's call it sum to infinity 1, becomes the A using this formula, the A, which is a quarter over 1 minus r. My r is this, 1 over 4 squared. Okay, I'll work out what that is right there. I'm going to add them. I'm going to do the series in blue now. There's 2 series in 1. All right, so I'm going to do the series in blue now. See what the values are on this one. So the A is this, 2 over 4 squared. So the A for that series is 2 over 4 squared. So one can simplify it and put it as, this is 16, 2 over 16 is 1 over 8, but 2 over 4 squared. And the R equals, what do I multiply this by to get this? Well, the 2 is a constant, that don't change. But the 4 squared has gone to 4, to the 4th power. So again, it's 1 over 4 squared. That's what I have to multiply this by to get this. Because this power was increased. This power, sorry, was increased by to 4 on that base 4 number there. So this is my common ratio. So this second series is to it here so now as a sum to infinity, sum to infinity 2, which is equal to now this A. I'll shift this down here, so I'll shift the second series down below here. I'll leave that this and shift this down here, so push down here. So. Right, so the second series, the blue one, as a sum to infinity, this is my A, which is 2 over 4 squared all over 1 minus, this is my R, 1 over 4 squared. And this one can be simplified quickly now. Multiply the numerator by a 4 squared and the denominator by a 4 squared. Numerator becomes 2 over 4 squared minus 1. That's what this denominator becomes, 4 squared minus 1. I can simplify this one as well by multiplying numerator and denominator by 4 squared. So for this one, the multiply numerator and denominator by 4 squared, remember what it becomes here. Becomes equal to. Multiply opposite by 4 squared, we get 4 over. Multiply another by 4 squared, we get 4 squared minus 1. So we now adding these two, add them to get the sum. So I'm gonna add these two. My sum, let's put in purple, different color. My sum to infinity is sum to infinity 1 plus sum to infinity 2. I'm adding those two things. I have the same denominator. So the numerator becomes 2 plus 4 is 6. Over the denominator is 15. Because this is 4 squared, which is 60 minus 1. 15. And then 6 over 15 can be reduced to 2 over 5. Divided by 3, we get 2. Divided by 3, we get 5. Yeah, 2 over 5. That's my sum to infinity there. See that? Good?
Yes, sir.
All right. So let's do another one. 2023. It's the 2023. 2014. It's the 2014 answer. Is it in here? Is it there? Almost 2014. In here somewhere. I don't know, man. I keep opening up the files I'm on there. And they're getting plentiful. Let me search for it. Not finding it. Yep, it's on here. Let me see. I can use it. Let's write it on it. So there you go. See if there's any on it. All right, so on here, we got the question. It's one down there, so. What happened there, someone? What happened? What happened? What happened? Okay. All right. So, teacher, this is the GP. This is the series. I like to set GP to it. I think I set GP far more than I set AP. Got that one. It says, given a series is given by this, show that it is geometric. It is geometric if it has a common ratio. That's what I would say. It is geometric because it has a common ratio R. So that's what I would say, part one. Has a common ratio. I know right what the ratio is. R equals this divided by that. 0.02 over 0.2. What is it though? It's 1 over 10, right? I keep multiplying by 1 over 10, don't it? Because I keep dividing by 10. So keep divided by 10. So the common ratio is 1 over 10. What do I multiply this by to get that? 1 over 10 or 0.1. Keep multiplying by 0.1. So this divided by, this time this is 0.1, right? So I'm going to show it like this. So this divided by this equals this divided by that. 0.002 over 0.02 equals this divided by that one. 0.0002 over 0.002 equals 0.1. And so on. So I'm going to put the three little dots and say equals 0.1. So I show that it is a common ratio. That's what I've done using all those values. That's the first thing. And if since my ratio is this, it says find the sum to infinity. That's all I know. The sum to infinity for part 2, sum to infinity, write this better. Sum to infinity is A over 1 minus R equals, this is the A right here, 0.2 over, around there, 1, 2, 1, 2, just want to double check something. So this is really 0.1. Just want to make sure. So that becomes 2 over 20. First one. 1, 2, 2. 1, 2, 20. Which is 1 over 10, yes. Which is 0.1. All right. So make sure. Brain kind of tired now. And then now I'm doing 1 minus 0.1. This becomes 0.2 over. This becomes 0.2 over. This becomes 0.9. Question say, given your answer as an exact fraction, this becomes 2 over 9. That's an exact fraction. 0.2 over 0.9 becomes 2 over 9. That's it, done. 5 marks, 2, 1, 3, 5. All right, let's look at 2015. All right, so far?
Yes, sir.
All right. 2015. I make you start the sum now for the sum. Try some of them and let's watch me do them. 2015. Da 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 da. Let's look at this one right here. How do I do this? All right. All right, so one here. That's what this one is right here. It says an employee of a company is offered an annual starting salary of $36,000, which increases by $2,400 per year per annum. Determine the annual salary that the employee should receive in the 9th year. So in other words, what is the 9th term? That's what this question asks to find. What is the 9th term? So it's kind of easy, you know, because if you start with this, look at this. If you start with this amount, and every year you increase by this, then in the 9th year, you'd have increased by this 8 times. See that? Don't it? That's all.
Yes, sir.
So you'd have started out with 36,000. And you'd have gotten this amount increase 8 times. 8 times you'd have gotten that amount. An amount of increase. Get it first year, then second year, get it again. So you have gotten this increase 8 times. But to do it as a APGP, it has said the A equals $36,000. The common difference is $2,400. I'm trying to find the 9th payment. This is the first payment, you know, and they're increasing by that every year. So the 9th term you're asking for, which is the 9th payment or the 9th salary, is A plus AD, A plus N minus 1D. That's how we still get about the 36,000 plus 8 times 2,400. And that is it. Whatever that works out is the answer. So the question is not difficult. Really, really straightforward. I mean, I can tell you. Can move on? Go to that?
Yes, sir.
All right. Let's look at 2016. Da, 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 da. Please. All right, let's see this one. 2016. Oh, that's when I started to allow us to write. But the first year, came with all these lines. Just didn't work out. Just did not work out. Did not work out. Bugger lines. Now, this is our summation, you know. This is actually a summation. And it will more than likely sum into an AP or a GP. And the first thing I would do for this question is actually start the values and see what they are. I'm not going to work with negative power, so I'm going to express this as the sum, firstly, from 1 to 25 of 1 over 3 to the n. That's what this is, 1 over 3 to the n. Make the pen smaller, thinner, and right over. Right, so first, as I said, I'm going to write it as the sum from 1 to 25, so I can see what kind of series it is. I'm going to do all the negative powers. I'm going to write as 1 over 3 to the n. I'm going to write out the first couple of values. That's what means, you're summing the values. So first, when n equals 1, you get a third plus 1 over 3 squared plus 1 over 3 cubed. And this goes all the way up to 1 over 3 to the 25. So that's actually 25 terms there now. What is this? This is a GP. This is a GP. Because you see, you keep multiplying by a third. First term is a third. You keep multiplying by a third. So the common ratio is a third. And the number of terms you're adding is 25. And you want to sum those values. So using the sum of a GP. Sum of a GP, right up here, and then just apply sum to n terms is a into 1 minus r to the n over 1 minus r. That's what I'm using. So the sum down here to 25 terms. Let me do it in red so it can show better. And it's the blue not really show so well against the black. So the sum 25 terms equals the a first, which is a third, into 1 minus the r is also a third, raised to the power, the n is 25, all over 1 minus the r again is a third. That is it.
So these summation questions are normally GP.
Now you have to just write it out and so you get. This clearly gonna be a GP. As you see, this power business I keep, that's why it's a GP. Because you see that to go from this term to this term is a GP. You keep multiplying by the same value. Each term is a multiple of, is a 1/3 multiple of the one at the previous term. So so it's
So
a
you're
GP.
just going up to 25.
Yeah, because this tells you that. That's what that means. So the sum of this expression from n equals 1 to n equals 25. So there are 25 values there, 25 values. Understand? And you realize it's a GP. Based on what the values are. These values form a geometric series. And this is the sum of a geometric series. A into r, 1 minus r to the n over 1 minus r. You put this in the calculator and work it out. If anyone sharp, just give you a 0 and almost, what? Don't put it in the calculator and see what we get. Because if you work it as a sum to infinity, because a third raised to the power 25 might actually be a very small number, and it might be 0. Let's bracket this up. The third close bracket raised to the power 25. I just want to see what it is. See, a very small number, almost 0 that, So this answer for this maybe is a sum to infinity, That's a bit 25. 25. I'll put in other parts of it now. You're gonna have a minus in front there, 1 minus. This goes into a bracket. That goes also into a bracket. You have a third multiplying it out the front.
So how would this ever be a AP question though?
What do I say? I don't know. This wouldn't be. You can set up one where you're adding. You have a more arithmetic progression, a more linear. Like for example, if you had, for example, the sum of from 1 to 25, or for example, 2 plus 3n, for example. If you have say you have 3n plus 1, then 3n plus 1. Let's change this to red so you can see it better. I'm gonna start to write down a couple of my terms and put it down here. Put it down here. I can't take them lines the end of the way. I can't deal with it. Right. So let's say I have this. And you start it out, right? Start it. So you put in the first term. You're gonna get 4. You put in 2. You put in 2 here, so you get 7 plus. You put in 3. You get 3 is 7 you get. You put in 2, you get 6. 6 and 1 makes 7. Put in 3, you get 3 is 9 and 1 make 10. You see there's a AP that keep adding 3. So this becomes an AP now. And so you're going all the way up to, you know, your last term is 3 times 20, 3 times 25. That's 75 plus 1, it becomes 76. That's what it is. So it becomes a AP. The A equals 4. The D equals 3. The N equals 25. The L equals 76. The last term is 76. So remember now that the sum, let me shift this up a little bit. The sum, you know, last term becomes n over 2 into A plus L, which becomes the N is what, 25 over 2 into the A is 4 and the L is 76, which becomes half of 80 plus 25. Let's work it out. So it becomes 25 over 2 times 80. So I get 1,000. That's what it becomes, 1,000. Now, you can try to get it the other formula. So n over 2 into 2a plus n minus 1 times d. Let's try getting it and see if we get 1,000 as well. So to be n still is 25, right? 25 over 2 into 2a. That will be 2 times 4 plus 25 minus 1 is 24 times the common difference, which is 3. Common difference is 3. Let's see if we get it off that one as well. We'll get it if this inside is equal to 80. Right, so let's see. So this is 8 right here plus yeah, that's 76 as well, right? 72. Yeah, that's 72. 24 times 3. See, you get 18 here still. So you get the same 1,000. That will be it. So you can get a summation that results in an AP, as this example did. But you see, you would know enough if I say this is a multiple, and this one is a power. See, the n is in the power. That's what happens. But n is in the power, it becomes a multiplier, like, you know. So that is it. Anyway, that is that one. All right, your time. 2017 next.
So there was another question.
Huh? There's another
There was
question?
another question, yeah.
Oh man. Oh man, oh man, oh man. Okay. All right, yeah. This one says, written with part of the lines. A man invested X dollars in a company in January, right? Remember this question. Concentrate and focus because the time is careful. So a man invested X dollars in a company in January 2010. January 2010, on which he earns quarterly dividends. He earns quarterly dividends. Every quarter he gets dividend. At the end of the second, third, and fourth quarter in 2011, much time gone. Remember in January as it started in January 2010. So in 2010 done, you gone 4 quarters already now. Because a year has 4 quarters in it, right? So you're going 4 quarters. So you're starting at January, and then you get a quarter. So July is the middle of the year, and you have December, right? So January, February, March, I must say April, that's so, right? And then August, something like so. So the 4 quarters are here. 1 quarter done so, 1 quarter done so, 1 quarter done so, 1 quarter done so. So there has 4 quarters in it. You start at January, right? So when January 2010 done, he has completed 4 quarters already. 4 quarters gone. All right, 4 quarters gone. All right, so he earns quarterly dividends, and at the end of January, you would have earned 4 quarters, 4 times. At the end of the second, third, and fourth quarter in 2011, so this represents the 6th terminal, and this is the 7th terminal, 7th quartile, and this is the 8th quartile. Those are the terms I gave us, because when January done, you done 4 quarters already. The second quarter in 2011 is the 6th quarter overall. So you have 4 in 2010, and you just reach the second one in 2011. So that is the 6th quarter so far. And they're telling us that these are the dividends. Right? So see there at the end of second, third, and fourth quarter, he earns 100, 115, and 130. That follows our AP, respectively. Calculate total dividends on his investment at the end of 2016. At the end of 2016, so you have to know how much years that gone, how much quarters that total gone from 2010 to 2016. But the first thing is that this information here will allow you to find the A and the D. Because you see the 6th term, it is A plus 5D is equal 100. So you can write that. I mean, you can look, you can see right here, so the D equals 15, Good. So the D equals 15 to begin with, right? So we don't have to calculate that. The D equals 15. So the D equals 15. And then this now, which is A plus 5D, is equal to 100. And the D is 15 in here. So it means that the A equals 100 minus 5 times that 15. If I take this and bring it over here and subtract it, but we'll put in the D equals 15. That gives us what? 25? So we're going to get 100 minus 5 times 15. Yeah, 25. So the A equals 25. So that's the original amount at the end of the first quarter in 2010. So you know you have your A and you have your D. The question is, how many quarters are there between 2010 and 2016? That's it. They want to know the number of terms. How many years is that? You have to include the 2010. You can't go subtract them, That's the beauty about it. That's the thing about when you're doing these things in years. You can't just say 2016 minus 2010 and say it's 6 years that. It's actually 7. Because you have to include the 2010. Look, if I list them on for you. You have 2010, when them start, 2011, 2012, 2013, 2014, 2015, 2016, and going all the way down to 2016. That's 1, 2, 3, 4, 5, 6, 7. So 7 years that of dividends. Plenty people want to get the wrong time because they're going the wrong number of years that he paid for. He actually paid for 7 years. Enough of people go into 2016 minus 2010 and get 6 years. And those 6 times 4 quarters give you 24, which is wrong. Because when you subtract 2016 minus 2010, you are not including the 2010. You have to be mindful when you're subtracting years, time in years. Because when you're subtracting, not including the one that you're subtracting. Right? to be careful. So this is actually 7 years of payment because you have to include the 2010. So he did it for 7 years. So it's 4 years, 4 quarters, there's a 4 quarters, there's a 4, 4, 4. These are all 4 quarters. Each year, you get dividends for 4 quarters. But in that 2016 is his 28th term. It is 28 terms, 28 times he has been paid a dividend. So you want to sum to 28 terms now. So the sum to 28 terms of an AP, it's an AP, you know, is the sum to 28 terms becomes 28 over 2 into 2 times A, the A is 25, plus N minus 1, 28 minus 1 makes 27, times D, the D is $15, 15. Work that out and put the dollar sign in front of the answer, and that is it. That is it. When you work this out and just put the dollar sign in front of it. Because it's money. The sum of money, sum that he earned. So you're adding up all the earnings that he had. Understand that?
Yes, sir.
So it's an example of when you're doing these questions, you get time in years, you have to be careful.
Check.
You have to be careful. Don't just subtract. Right? You don't just subtract. You have to add. Remember, when you subtract, time means that you're not including the first period in your when you subtract. What you're calculating is the difference between. So when you subtract, so you have to add back the time in the first period. And if you have to add back the first period, you take the difference and add back the first period. All right, so that is what is happening there, as you could see. All right. The next one is 2017. 2017. Then there was a tricky one on 2023, you know. A tricky one on 2023. And one of the reasons why it's tricky because they use the word sum. And even though they use the word sum, you're not calculating a sum. You're actually calculating a term. Okay, we'll find it and show you. Can I remember it? 2023. All right, let me see this one. See if there's any on this. There's always like a small one on them, you know, I think it's a fairly popular question. They don't come every year. They can't set everything every year. But see this one. Got two. All right. You see this one? I never like that one here. Jesus. I remember this one. I hate this one. Because what happened is that with these big values, the GP, you know, what happened, you had to use a large number of decimal places and the common ratio for it to be accurate. Because when you multiply a number by such a large value, you have to round off your value like your R to a large number of decimal places because it is being affected by a very large value. So to ensure the accuracy of it, I have to use a large number of decimal places. Okay, I'm multiplying it by what? Tens of thousands. So you can't run it off too close, too small. You run it off to a large number of decimal places to increase the accuracy of the calculation. All right, good. It says an accountant is offered a 5-year contract with an annual increase. The accountant earns a salary of this and this in the 3rd and the 5th year, respectively. If the increase is geometric, calculate the amount in the 1st year. This is asking for A. It is geometric. Well, this is the third year. That's the third term, and this is the fifth term. That's all that is. So, third term is AR squared by AR to the n minus 1. So basically then, AR squared is equal to this figure. I don't know what CSEC was thinking about when they gave the big long number there. But let's write it out with all the different values. Like they're trying to show somebody under the bus. 53982.80. And then this is the fifth term, which is AR to the fourth power. So AR to the fourth power becomes that second figure, 60598.89. No, all them whole digits there for. So you're solving these simultaneously. They ask for the first, they ask for the first term. So it's A more. But we also find one R. So to solve these two simultaneously quickly, we can divide them, right? I'm gonna divide them. So I'm gonna divide. I'm gonna do this one divided by this one. When I divide this side by this side, the A is gonna cancel. For R to the 4 divided by R squared, it's gonna give back R squared. So I know I'm getting R squared on the left side equals. I now need to divide this figure by this figure and square root it. No, I'm not gonna bother with the negative square root because they tell us that actually is an annual increase. So the money getting more and more. So the common ratio can't be negative. So what I'm gonna do to do one calculation, I know that I have to divide this by this. So I would have had this figure 60598.89 over this figure, which is 53982.80. And then to move this square, I'm going to square root this and drop off the square. You good with that?
Yes, sir. Okay. I got the answer, I think.
All right, what you get?
1.0595.
Right, that's the thing about it, you know. Because you're multiplying the common ratio by such a large number. To increase the accuracy of your values, you have to use a large number of decimal places on this question. All right. Let me see. Square root of a fraction. 60598.89 over 53982.8. Yeah. So 1.059. I'm gonna go. This is how much digits that? 5 digits. I go to 1 decimal place more than 5. I go to 6 decimal places. All right. So I have to multiply by a very large number. So I'm gonna put in my 508. Put in my 508. What's that? 6 decimal places. I'll put in one more and change this to a 9. I'll work with that, right? This is 1, 2, 3, 4, 5. Yeah, 6 decimal places good enough. So I'm gonna use the 9 that is on the 9 that is here, increase that to 9. So I'm gonna make this be 9 right here. So 6 decimal places because it is 1 more than this number. It's that digit.
To be more accurate, would you use all of the numbers? To be more
what I'm gonna do
accurate,
now,
would you?
So right now, to get my A, I'll leave the figure there. That is in the calculator, you know, to get my A, you know. I'm gonna leave the figure that's in my calculator to get the A. Remember, you know, you see the R squared that you're seeing right here, so this is equal to this fraction, you know. Remember, you know, the R squared is equal to this fraction, right? And so this value divided by this fraction actually gives you an A to get the accuracy of it, right? So we can look at this. So we know the R is that good, but the A becomes this figure over r squared. Look at it now. The A is equal to this figure divided by r squared, where r is this. R squared is this fraction. So it becomes 53982.80 over r squared is now this. So I'm getting back the 60598.89 back over the 53982.80. So what it is really is that if you square this, right? If you square that, then you get a r to the fourth power in this and a a squared. Right? And then when you divide them two here now, the r to the fourth will cancel the r to the fourth, and the a will cancel that a there. That is what this calculation is showing us. That's what would happen. But I did it away where we calculate the r first. But this is gonna give you an accurate value for the thing there. So that's why this now will come up here and square this. It's the same thing, but I'm gonna work it out with the calculator as is. So I'm gonna take about the square. Think about the square root of this. Can I think about the square root of it? I don't even know. All right, let me just type this in the calculator. So this is the same as this denominator up here, so squared in it, the same thing. So let's put that fraction 53982.8 squared.
So take off the square root again, why?
Huh? No, because I
Take
want
off the
r
square.
squared. Because I want r squared.
Okay.
So I'm putting that over the 60598.89. Same figure there, that's my A. But because it's money, let's put two decimal places, right? That's the amount in the first year. And I also know my R. So I'm gonna put the dollar sign on it now. Dollars. 48089.04. That's what I'm gonna put. .04. That's the amount that he started out with. All right. All right.
Yes,
so I have my R. So I have my R. I have R. And I have A. Can't find anything now. Next part one, the total salary earned at the end of a contract. The total salary that he earned at the end of a contract. So that is the salary. The first year plus the second year plus the third year, you want the sum of all the salaries earned. So how many years did he work for? The contract was for how many years? So you can know how many terms, how many times he was paid. Was offered a 5-year contract. See? So you want a 5 years, sum to 5 years. That's what you want, the sum to 5 years. So this question is asking you for the sum 5 years, which is equal to A into 1 minus R to the n, which is 5, over 1 minus R. So it becomes equal to, what is now, a figure here, 48089. Don't know 6 here, they never settle them question in the more long digits here. There's some in a sense. 48089.04 bracket 1 minus the whole long ratio here, so now for the accuracy. 1.059509 raised to the power of 5 all over. Let's shift all this over to the left. all over 1 minus the R again, 1.059509. Write that out and get the answer in dollars. So they're difficult, but it's just tedious with all them of long digit values. It just doesn't make no sense to me. I don't know what they're trying to prove. So it's 48,089.04 times, I just put the bracket, and that is 1 minus 1.059509 raised to the power 5, right? And then close that bracket, all over 1 minus 1.059509. So he earned total of 270,448.65. That's it. Enough is so bad this time. I don't know why, but that is it. Okay with that?
Yes, sir. You're
Where you want
letting
to
me
know?
do the next one?
Yeah.
Okay.
2018. All right, this one is easy. Do this one. See there? That's it.
Yes, sir.
I'm gonna pause on and eat my crackers. Get off here my crunching. I'm just mute.
All right, sir.
Anything yet?
Thinking.
You're thinking?
Yeah.
In a geometric progression, the third term is 25, and the sum of the first and second term is 150. So if it's just two terms, you want the sum of, just write them down individually. Now put them equal 150, the sum of the first and the second term. So determine the sum of the first four terms, given that R is greater than 0. So it's a simultaneous equation situation again, right? Let's write down the terms in terms of the A and the R. That's all I have to do.
I have 3 equals, well,
3.
okay, wait. 1 equals,
What do you mean 1? Where did 1 come from?
the first term,
You can't call the
or
first
is
term
it
1, call it A.
150 equals,
Let's wait say no, the sum of the first and the second term is 150. What is the sum of two values? Now add them. What is the first term of a GP? A. What is the second term of a GP?
A squared.
No, man. A, then AR, then AR squared, then AR cubed. The first term is A. The second term, you multiply by R to get it. It's AR.
Um,
And the third term is what? What is the third term? Just remember, a term is AR to the n minus 1 now. Term is AR to the n minus 1. So them tell me the fifth term, it's just AR to the fourth power. This first term is A, the second term is AR. The 10th term is AR to the 9th power. The 15th term is AR to the 14th power. The 8th term is AR to the 7th power. It's easy. AR to the n minus 1, 1 less than the term number. And they're giving you some terms. I just equate the term, equate the expression for the term to the value. That's all they have to do. So the third term is 25. The sum of the first and the second term, meaning that when you add the first and the second term, and it's just two terms, they don't need a formula for that, to add two terms. Just put on what the first term is, put on what the second term is, and add them, plus between them, it equals 150. So you're gonna get two equations. This is gonna give you one equation, and that's gonna give you a second equation. You solve them simultaneously. Remember what I told you, when you're solving simultaneous equations given by a GP, you divide them. Divide. It's a good tip to remember. Come on, man, the thing easy. Come on. Come to this one.
I have A plus AR equal 150, and then AR squared equal 25.
Good. So solve them simultaneously. But as I always say to you, a good tip to remember is that simultaneous equations that you get from GP, you divide them. Divide one of them by the next one, because that will always eliminate the R for you. The A, I mean. They will always eliminate the A. May divide. Remember, you know, in a GP, you know, everything is being multiplied by A, you know. AR squared, AR cubed, AR to the fourth, AR to the fifth power. If we have some terms that divide, even the sum of R in it. Remember, the sum to any number term is A bracket something, you know. So everything always have the A in it. So we get two simultaneous equations in a GP. When you divide them, you will cancel the A. Get an equation that you can find the R. Then after you find the R, you substitute back to get the A. So it's a quick way, a lot of the times, to solve simultaneous equations that are derived from a GP. The ones that are derived from an AP, we tend to solve those by subtracting them because they are formed through adding values. So to solve those simultaneously, you tend to subtract one equation in an AP from another one. That's like a general approach.
Subtract and divide.
When it's AP, I'm saying you subtract. When it's GP, you divide.
So AR squared divided by the A plus AR equals 150.
Yeah, equal 150, man. Come to 25. Dividing one equation by another equation. Look here. In my one equation, you say A equal B. And my one equation, you say X equal Y. I'm going to divide them. Then it means that the side over the side here, everything, the A over the X, I'm going to equal to the side A over the side here, B over the Y. After all, the A equal B, and the X equal Y. That's all.
Yeah.
So let's divide them. Divide the two equations. Divide the left side, the terms on the left side with each other, and divide the terms on the right side with each other. And put the equal sign between them. That's why I divide two equations.
Of R equal 1/6.
1/6?
Yeah.
No, I'm going to work it out. I'm going to finish it now. And so must determine the sum to four terms. After I get the A, after I get the R, you can use that and find the A. Now look here. Look here, let me show you something. If you know the third term, you never find the A, you know. From the third term, how do you get the fourth term? Because look here, look for the common sense of this question. Them tell you the third term. Them tell you the sum of the first two terms. You already know the sum of the three terms, they say, you know. So to get the sum of all the terms, you really only need to know the fourth term. You want the sum of the four terms. So if you know the third term, and you also know the R, what is the fourth term equal to? How do you go from the third term to the fourth term in a GP?
You multiply
By what?
by the R.
Exactly. So you absolutely don't need to work out the A for this question. See that? That means that you'd have had all the terms. All right, let me do it now. I think you reach far enough. So, question said that the third term is 25. So that means that AR squared is 25. Simple as that. It said the sum of the first and the second term. Since just two terms, if them tell me the sum of four terms is something. You might just list out the four terms, I mean, but I don't put no formula in. This is just two terms, the first and the second term. That's A and AR. Them say it equal 150. That's my two equations. I'm going to divide them. Let's say I'm going to put that one here on top of this one. Divide them. So I'm going to divide them like so. So I'm going to divide them. I get this over this. So the A's I'm going to cancel now. I'm going to get AR squared over And the A them are going to cancel. So I get R squared over 1 plus R equal this over this. 25 over 150. What is 25 over 150?
1 over 6.
1 over 6. So this equals 1 over 6. And this equal 1 over 6, you know. So I'm going to solve that. I'm going to cross multiply. So I'm going to take this and multiply it over here. And take the 6 and multiply it over here. Right? So I'm going to get 6R squared equals 1 plus R. Carry them over here so back and get a quadratic. 6R squared minus R minus 1 equals 0. We'll factorize this in order to find R now. 3R and 2R. Factor up this are 1 and 1. And they are different give a greater product, the minus. The greater product is this far product, make it minus. Make this plus. This factor giving me R equals negative a third. This factor giving me R equals half. This one is not valid. Why is it not valid? Because them tell us that R is greater than 0. So it's not valid. Not valid. So this is my R. So what do I have now? I want to sum to 4 terms. See it here now? Sum to 4 terms equal the first 2 terms, A and AR.
Sir,
The third term.
Sir, check this for me, please.
Oh.
I had the AR squared over A plus AR, and then I canceled the AR on the bottom. That
No,
was.
you can't do that. You can't cancel the AR on the bottom because it is being added with this. It's almost like you have this, you know, you factorize over the A. Like you have this, like you have AR squared over A plus R. Over A plus AR. You factorize over the A and you have AR squared over A into 1 plus R. And then the A is cancelled. You can't divide one part of an expression, you know. These are 2 parts. This expression has 2 parts in it. You can't cancel one part with some other stuff. So what about this? You get me? So that is it. So anyway, so this becomes A plus AR plus AR cubed plus AR to the 4th power. But this is really AR cubed times R. So I'm going to write this instead as AR cubed, which I have already. I determined that is AR cubed, the 3rd term, yeah, this. AR cubed times R. So the sum of the first 2 terms, that's a 150. I don't need to write them out. That's a 150. Plus this, the terms are 25. See there? 25. 25. Plus the 4th term is 25 times, what is R? Half. 25 times a half. 25 times a half. I can see it. You can see what the series is now. It becomes 100, 50, 25, and half of 25.
So you wouldn't use the
No, I'm not in the formula for this with just 4 values. Let me not share the volume already. And the 4th one is just multiply the 3rd one by R. I'm not going to use the formula and waste time. To use the formula, you have to calculate A. Don't need to calculate A for this one.
Okay.
Just don't need A. That is it. You realize that the series is correct. This 150 is made up from 150. I see the common ratio as a R. all the values keep multiplying by half. So start with 100, half it to 50, half to 50 to 25, and then half to 12.5. Those are the values. But this line is sufficient for me to work it out. They gave me this first two terms. They gave me this one. Now that I calculate my R, I can find this one. And my fourth term is just my third term times R. That's it. That gives me the sum of the values. All right?
Okay.
All right, let's look at 2019. There's anything else. Take this off. All right, now I'm going to leave it. One more. Okay, that's work out where it come to. It's 175 plus 12.5. It's easy enough. 175 plus 25 over 2. Yeah, 187.5. That's it. No, 1090. I can come on every year, man, so far. I can come on every paper.
Yes, sir.
Looks so far. Let's see if the trend will break. Nope, there you go. Here's one. It's a GP. Let's prove that sum to infinity is that. Come on, it's uneasy. I give it this series, and I'm tell you to prove that this will be the sum to infinity. I have remembered that sum to infinity is a over 1 minus r. That would have been on the formula sheet. That's the sum to infinity. A over 1 minus r. Right? Let me see the formula sheet short. The formula sheet on this. Yeah, see there? I give it to you. It's good to remember those things. Right? So that is that. So come on, you just want to identify the A and the R in this expression. Easy, come on, this one fast. And then you prove say there's something from the works out to that. No calculator needed on this one, there's some values. Which anywhere?
I've got s to infinity equal y over x over 1 minus 1 y over x squared.
All right. You know what, yeah, but it's supposed to work out to this when you're done. What is this have a -4 on it? So this is the same as xy over x squared minus y. It's -4. Give it that. So this
Okay.
and this is the same thing. If you work towards getting this xy on top, it will work out itself. Sure. Whatever expression you have, just make the adjustment. And usually you make the adjustment by multiplying by some value. Numerator and denominator by some value. You have to learn that skill. Right? To get what you want, to get what they tell you to prove.
I have y over x. I'm not sure where to put the 1 minus value. Put that as the exponent -1.
If one minus one, I don't know.
There I have y over x divided by 1 minus y.
Oh yeah, y over x.
Yes, y over
Alright.
x.
Let's see. You have y over x, that is a over again.
Over 1 minus y over x squared.
Y over x squared. You're not gonna clear then, man. And you want to become a xy. And you don't want the x squared under your so. So what you do if you don't want the x squared under your so? What you do?
You flip it.
If you have a fraction like
Yeah.
this, if I want this to become a xy, what do I multiply it by?
You want it to become a what?
This xy here. How do I get this to become that? What do I do with it? Brianna, you have to learn this, you know. Look, you have to learn stuff like this. Look, I'm doing it 1 million years now with you. Multiply to get rid of the fraction under here, so I don't want it. I multiply by x squared. I multiply the denominator as well by x squared. And it works itself out like a charm. But also look at it another way. Instead of 1 year, I want it to become an x squared. How do I get 1 to become an x squared? I multiply by x squared, so I know that I need to multiply the denominator by x squared. If I multiply the denominator by x squared, I also have to multiply the numerator by x squared. It works out itself. You have to learn that skill. This times this gives me x times y. This times this gives me x squared. This times this cancels the x squared and give me minus y. And all I have done in this expression is take the denominator and bring it up and put a -4 on it. So this becomes xy bracket x squared minus y to the -1. You know, in a sense, you reach us and can't finish it, you know? We all need a simple thing like that, and you have to practice doing these things and make it become second nature at this level. You have to be able to make those kinds of adjustments. When you start the math at this level, you know, that only about canceling things, you know, and simplifying, you know. Something you have to build up stuff. You have to adjust how things look, and you have to look how you adjust them. You have to develop the skill of multiplying and dividing by values to get what you want. You have to do that thing in a red. You absolutely have to get that skill. That will be like second nature to you to do that skill. Have to. All right, mom?
Mm-hmm.
All right. Look at another one. So you got to here. But you have to know no, so you have to do this to finish it. Right? You have to do that to finish it. All right. That was our 2019. Look at 2020, 2021, because there's no exam in 2020. Well, it's on this AP, come on every paper. AP, GP. Try to realize that before. And some topics come so rarely, I tell you. It's not really on AP, GP, but I guess come on the see if there's a proper AP, GP. That question is kind of an APG, but not really. It's really more like a serious question. But kind of a spin off from a GP, this one. That one, let me see. Look on this, you know. Um, so they give you this formula, just spin off from a GP formula. Not even really a GP, it's like a formula. This is more indices question, you know. That's what this question is really, you know, more an indices question, more than a serious question. It's not really an APGP. I'm looking for proper APGPs on it, but that's not the APGP. It is more like indices, logs and indices, indices question more than anything else. I still want to try it still on them. You get him, but not really a APGP. There's more just a thing there, you know, like you have a formula. Yeah, try for a question. So determine the number of years, in other words, T. Determine the number of years T that would take Alice's money to take Alice's money to at least triple. So you want the money to triple. So you want the amount to be triple what this is. Triple. That is the question. Yeah, this formula. Where them say? Them say Alice deposited $4,000 in a new bank savings. So this now is the amount of principal. Amount deposited is always principal. The compound interest formula is really, you know, is it that them Bank of Fortune, which pays 8% interest. So this is the R. The R equals 8 right there. The percentage is already taken care of with the 100 and a year. Right? The bank, the bank's compound interest is represented by this geometry, by a geometry progression on this, where A is the amount of money accumulated after time. So A is the amount accumulated inclusive of the interest. That's the amount of this 1 plus the interest rate there. So it's the amount accumulated. So if them never tell you, know, inside or outside, would that just be 1.08, you know, that's what it works out to be. And you have the principal amount, which is like your A, and you keep multiplying it by this amount every year. That's why you have T on this. So that is the amount you have in there. But after the first year, this is 1. After the second year, that becomes 2 and so on. So that is the formula really. But anyway, it says boom, bang, boom, bang, boom, bang. It says T is the time in years, R is the rate percent of interest per annum, and T is a positive integer, time in years. But to repeat that, okay. determine number of years. Number of years is T them want. It would take for our payment to triple. And when the payment triple, I mean that the amount is equal to 3 times the principal. The amount that is there is equal to 3 times the principal. No, lie. Yeah, the amount is there is now 3 times the triple because the A represents the amount that is in there. The amount that is in there. So if you it's like if you put in $100, you want it to triple to $300. So this would have been the P, and this would have been the amount that you have accumulated if it was triple. From this relationship, you can see that the amount is equal to 3 times the original amount. So that proves it. That's what you're basically doing with this question. Finding T from the equation here when the A equals 3P. Very easy question. You don't even need it. You don't even need it, the P. No, end up that you don't need the P. So could have actually given this question without telling the value of the P. You know? Yep. Could have done that. That's not what I'm seeing here. Anything?
I just started. A equals 3.24 to the T.
That's a T I try to find time. But when the thing that you're trying to find is in the power, you have to take logs to get it out. Remember that.
Repeat?
When you're trying to find a value or a variable or an unknown quantity that is in the power of an expression, you have to take logs to get it out of the power. Remember that. When the thing you're trying to find is in the power, you have to take logs to get it out. Get it yet? All right. It take too long, man. You understand this? That
Yeah.
amount is all right. So let's plug them. Let's plug those values now into this formula up here. So it means that A is 3P. So the amount accumulated is 3 times the amount that was originally put in. This is equal to the amount put in into 1 plus the R is 8 over 100 raised to the power T that you're trying to find. This principal cancels this principal. So therefore, this side becomes just 3 equals inside that becomes 1.08 raised to the power T. Simple. Take the logs of both sides. I want to get this out of the power, take the log of both sides, take the log of this side and take the log of that side. And this power comes to the front. So you get the log of 3 equals T times the log of 1.08. Take the log of 1.08 and divide it on a year. So the time becomes the log of 3 over the log of 1.08. That is the T. So fraction log of 3. Log, where's my log? Where's my log of 3 over log of 1.08? That's 14 years. So I'm saying at least triple and determine the number of years. So I'm going to put 15 because at least means triple or more. So if you go longer, if you put 14, triple yet, it's 14.2 something. Remember the interest is paid annually, right? So you put 14. Since the T coming out to 14.3, call it, the time required then, number of years, for it to at least triple is 15 years. I got triple after the year done because it 14 and a third year, basically 14.3. You reach 15 years yet, I'm only triple. We're not getting it until the year done. So we'll go to the end of the year. If we go to the end of this year, which is now the 15th year, you have completed the 15th year. For the month you triple. So I just have to put the answer. 15 years. So I put 14.3. Understand?
Mm-hmm.
You have exam tomorrow?
No.
Oh. 2022. I could do all of them, man. You could do them over back, They're all in the group.
Yeah.
2022. Okay, easy one, this one. Easy. What have another part here, sir? 2 parts. All right. So A and B. B and C. Let me see this at GP. It says, UC University graduate was offered a starting salary that for the first year an increase of 5,000 was started. And 5,000 at the start of each year thereafter. Determine number of years. The nearest whole number that it would take for a salary be 20% greater when I start. Determine number of years. nearest whole number that it would take for her salary, your annual salary, to be 20% greater. So this is asking for a term. This question is not asking for a sum, it's asking for a term. In other words, oh man, got the wrong thing, Chuck. I'm going to take off this. Right. So it's question down again. It's salary they ask for, the salary. When the salary reached 20% greater than the starting salary. So whatever the starting salary was is what this. They want to know when the salary, which is the T term, comes 20% greater than that, means 120% of that figure. So you're trying to calculate when you calculate the value n for which it is equal to that. So one, the other one first. That's one straightforward.
So it's 20, the difference is 20 and then 21 and then 20.8.
That is a GP. It's a
Oh, you
GP.
sure?
And the difference cannot change. The difference cannot change. It's a common difference. It's one common difference, but it's a GP. It then shows that it is geometric. They're looking for a common ratio. They say it is geometric. They are looking for a common ratio. To show that there exists a common ratio between all the values. So for sure. So what the common ratio is. To go from value to value. It's pretty obvious.
Common ratio is 5.
Can't be 5. You have to take the sign into consideration. Can't be 5. Look, what value takes me from 25 to negative 5? Put better, what value takes me from 1 to negative 1 over 5? So you can find
So
out what value takes me.
there's no commas.
Huh?
There's no commas.
It no matter.
So
You're
I
adding the
thought it
values.
is.
It's a series. This is the first term. So the first term here. This is the second term. This is the third term.
I thought
This
I
is
was
the fourth.
supposed to subtract and
No.
then add.
Huh?
I thought I was supposed to subtract 5 from the 25, then add the
We are
1.
subtract them for. This is a series. A series is a sum of values. Okay, so this is the same as 25 plus negative 5 plus 1 plus negative 1 over 5 plus 1 over 25. It's still a series. You're still adding values. Right? Let me write it over again. It's the same as 25 plus negative 5 plus 1 plus negative 1 over 5 plus 1 over 25. A series is formed when you're adding values that are following a set pattern or relate to each other the same way. What's the relationship between these two numbers here? What's the relationship between them? How do I go from this to this?
Yeah, subtract 20.
No, it's a geometric series. Once it is geometric, there's no subtracting. It is geometric. See? Just until you show that it is geometric, forget about subtracting. Geometric is about multiplying. What do I multiply this by to get that? What do I multiply this by to get that? What do I multiply this by to get that? A geometric series has a R ratio, something that they keep multiplying by to go from term to term, multiply, multiply, multiply. Go from term to term, you keep multiplying by this one constant value. What is that value?
Negative 5.
Hmm?
Negative 5.
No. Common ratio is a term. If I multiply this by negative 5, I get negative 125. Is negative 5 may have this so? What do I multiply
Not.
this by to get this? What do I multiply the first term by to get the second term? All right, I told you earlier now. I told you that the common ratio is equal to a term. It's not good enough. Divided by its preceding term. We have the terms. The common ratio is a term divided by the preceding term. So for example, it is the fourth term divided by the third term. Gives it a common ratio. A term divided. Why is that? Because we take the third term and multiply it over here. It shows that my third term times the R equals my fourth term. See that? So this will always tell you what the common ratio is if it is geometric. For the arithmetic, the D is a term minus the preceding term for the common difference with the AP, for the AP. For the GP is a division thing because GP you go from term to term by multiplying by a common ratio. So if you want to know what that common ratio is, you divide a term by its preceding term. So look at it again, man. Come on. The ratio don't have to be no whole number, you know. You see the common ratio? It can be any value except 0, and it can't be 1 either. It can't be 0, it can be 0, you don't have no values. And if it's 1, the values are just repeating. So it can't be none of them two values there. It can be any other real value, the common ratio. Okay, you can multiply by any value. Fraction, positive, negative, whole number, big number, small number, no matter. To know what it is, you divide a term by the term in front of it. Come on, man. The values are right there in front of you.
Negative 1/5.
Exactly. 25, no, not 25. A term divided by its preceding term. This divided by that. See? Minus 5/25. Same as this divided by that. 1/-5. Same as this divided by that. Minus 1/5/1. Same as this divided by that. 1/25 over minus 1/5. All of them equal to 1 right so. Minus 1/5. That is a common ratio. And because it has a common ratio, as every pair that you divide, 1 divided by the one before, 1 divided by the one before, 1 divided by the one before. In all cases, you're getting a value that is the same, negative 1/5. Another way to look at it is to say, what do I multiply this by to get this? Negative 1/5. What do I multiply this by to get this? Negative 1/5. What do I multiply this by to get this? See there? It's 1, you know. Look. Look. That pair is supposed to show it, you know. That pair in the middle. Supposed to make you see what it is. How do I go from this to this? From negative 1/5 to 1. How do I go from this to this? You have to multiply by 1/-5 to cancel it, to give me the 1. All right, upon the next way. How do I go from 1 to this? You have to multiply this by the value there. See? So that shows you the common ratio. Right there, so the R equals minus 1/5. I have to multiply 1 by minus 1/5 to get minus 1/5. But generally speaking, the values are not so glaring like a value of 1 in there as a term. Then it's a term divided by the preceding term, divided by the preceding term. So it's minus 5/25. I cancel it. Or I can use this one. This one divided by that one, which is 1/-5. Same thing. Or it is this one divided by that one, which gives you just the minus 1/5 divided by 1. Minus 1/5. So that is the R right there. And then what is the A? What is the A?
25.
Exactly. So when you have those values, they're good. But to show that it is a GP, I just have to show me, just show you what I go. Show that it is a common ratio. Show all the division. So to show that this is a GP, you have to show that it has a R, a common ratio. The GP, it has a common ratio. So that's what I said to the examiner. It's a GP because it has a common ratio. R, which is equal to minus 5/25. That's the second term divided by the first term. 1/-5. That's the third term divided by the second term. Minus 1/5/1. That's the fourth term divided by the third term. Or 1/25 over minus 1/5. That's the fifth term divided by the fourth term, which all works out to minus 1/5. So it has a common ratio. Show them that. That's why it is a GP, because it has a common ratio. Every term divided by the preceding term comes out to the same value. That's it. Then no, calculate the sum to infinity. Come on, it's just an easy. Do that part there quick.
20.8.
Okay. So sum to infinity becomes the A, which is 25/1 minus the r, which is negative 1 over 5. So I like this now. I simplify this quick. This becomes a plus. That's the first thing. That's a plus. I multiply this by 5 over 5. I said that 5 here, I cancel that 150. All right, so I'm going to shift this over a little bit. We can put in the calculator still if you want. So, with that, with this. So, my numerator will be 25 times 5 is 125 over 5 times this one is 5 plus 5 times that 150 is 1. So, 125 over 6. That's my answer. That's what I got. I don't know what you say. Oh, okay.
20.8.
All right. So you can leave the exact value that you have here. So leave the exact value. All right. All right. This part now. So you can part apart definitely. If you can do them enough, 4 mark field. You want to identify your A and your D. Because this one is the same increase. A recent university graduate start out with this. That is his A. Them start out with. I remember in a time question, A correspond to year 0. Year 0. Because when you start, it is year 0. The second term, which is A plus D, is year 1. That's after 1 year. So remember now that the N, when you have an N, the year is 1 less than it. It's N minus 1. You have to remember that. The number of years is N minus 1. You have to remember that. The number of years is N minus 1. Number of years are passed. When you reach a second term, you only go on 1 year. 2 minus 1. When you reach a third term, which is A plus 2D, you just reach you just gone 2 years. You have gone for 2 years. Year 2. 2 years pass. Start at 0, you reach 1 year, you reach the second term. When you reach a third term, you're done the second year. So the third term, up here, so the N would be 3. But the year is 2. So I say that the year equals N minus 1. All right? If you remember that. The term number minus 1 tell you the number of years you pass. You have to remember that with this question, the time question. I'm asking for a number of years since it starts. Stop biting me up in here. Jesus, I don't buy school enough. That's what I'm doing here from this afternoon.
So I tried doing the 120% times the 720,000 for the TN for
Yeah, that is the value of the
the
TN. That's what the
and
term is
then
gonna be.
yeah, and then I got 8,640,000.
Million?
Yes,
No, sir. Yeah, increase this by
because
20. Yeah, increase this by 20%. I get 8 million. That's $720,000 that, you know. If you increase that by 20%, you can't reach million, man. 120%. 1.2 that. I multiply by that to get the new figure. What the term, what the salary is going to be when it has increased by 20%. 20% more than that is 1.2 of it.
so 864,000.
Right. They want to know which term. They want to know which term is that. Which year the term is going to reach that. Remember, the term is A plus N minus 1 times D. So when that term reaches that figure, which is 1.2 times the 720,000, that's what we're trying to work out. You want to find the year, the end for that. In other equation.
So I have 864,000 minus 720,000 equals the n minus 1 times 5,000.
Times. Oh yeah, all right. And you solve for the n.
Yeah. 144,000.
So n yourself final.
Yeah, 144,000 divided by 5,000 equal n minus 1. 28.8 plus 1 equal n. 29.8 equal n.
29.
Then
29.8. Have a careful notice that at the end value, right? So remember now that a
30
year. Huh?
30 years.
You can't just jump and say 30 years. What's the n is not the end don't know what the matching number of years are passing. You must say the first term correspond to year 0, as I said. Year 0. The second term corresponds. That's how these are n values and n. I'm gonna put it this way. With this time thing, we start at a particular point. When n equals 1 for your first term, the year is 0. When n equals 2, it's the second term. You just gone 1 year. 1 year passed, the year equal 1. When n equals 3, the year equals 2. So the year is always tracking 1 behind the thing, the number. You get what I'm saying? The number of years is always tracking 1 behind the figure number, because the first term where n equals 1 in the series corresponds to when you just start. No, you're not past yet. You just start. So the year is 0. So when you get a figure like this, I put it at 30, because it's a number is I put at 30. The n equals 30. It means that the number of years equals 1 less. 29 years pass. Because this is the 30th salary. The 30th salary is what will put them to at least that. Well, let me work it out and show you now. Because what you can do sometimes is put the inequality in the information. This term when them say greater than the first year salary. Watch this now. When the annual salary becomes greater, instead of putting equal and actually put the greater than there, and it work it out for me. So watch this now. So firstly, the D is 5. Right? I'm next thing, I don't have to work with them 1,000 here now. I know that I'm working in thousands. I don't have to put that. I don't have to put the thousands. I'm working in thousands. So I don't have to work. I don't have to put that. I don't have to put the thousands. I'm working in thousands. So my starting point is 720,000. My thing is 5,000. So my A equals 720. My D equals 5. Right? I want my term, my nth term. I want my nth term, which is the Tn. Call it Tn. I want to know when my Tn is equal to 1.2. 1.2 times 720. 1.2, 20% more than this, times 720. I'm working in thousands. Keep it simple. So 720 times 1.2, 864. So I want to know when my T term, which is 864. What is my T term equal to? Generally speaking, my T is A plus N minus 1. No, let me say when it becomes greater than this, right? When the salary is greater than, when the salary becomes, let me see what it says. Read it. It says, determine the number of years to the nearest whole number. Okay, to the nearest whole number. That it would take for her annual salary to be 20% or greater than her salary. Okay. That's 20% greater. Okay. So you want to know when it becomes 20% greater, which is that. So it's an equal situation. I thought it was an inequality situation. Okay, that's all right. So it's the same solution that you did. When there are things that is not 20% greater than what she started, which is this, when the salary reached that. So that is when the term reached that. And what is the term? It is A plus N minus 1 times D. That is equal to 864. And you're trying to make N the subject. Well, if you make N minus 1 the subject, then you'd have found the time, you know. Because remember this, you know. Remember that the year is tracking 1 behind the N. The number of years corresponds to the N minus 1, you know. So if you calculate N minus 1, you'd have found the number of years. Number of years correspond to the term minus 1. And when you have the first term, when N equals 1 right here, so the number of years is 0. 1 minus 1 is 0. So this is like a formula for the number of years, which is good to remember this when time in years is included, or months or whatever. When the first value corresponds to when you start, and you want to know after how many years or whatever. So the number of years will always be equal to the term number minus 1. So if I use this formula and calculate n minus 1, then I have found my number of years. Right? So it's like I'm trying to find n minus 1 now. Right? So I'm just going to find out n minus 1, and that's my number of years. So the n minus 1 would be equal to 864 minus a, which is 720. 720 divided by 5. So my n minus 1, which is my number of years, would have been equal to a fraction 864 minus 720 over 5. That's 28.8, which approximately is 29. That is 29 years. Because n minus 1 represents my number of years based on this relationship. So it's 29 years to the nearest number of years. Nazan? Only 2023 left. I'm going to put that one up. I don't know if I have that one on the device. Let me look. Don't think I have it in here. Let me see. I want to leave you to do that one. There's a nightcap. Let's see if it's in here. Don't think it's in here. 2023. Oh, see it here. It's in here. All right. That's okay. I need to get a better copy than this because I want to work it out. I get up in the early morning and work it out. I'm gonna stream it and send it to you guys tomorrow. So this question is an APGP, right? 6 marks for it. That's 2 calculations. And I'm gonna leave you with it. And try it and tell me where you get tomorrow. I'm gonna maybe wake up in the early morning and do a video on it. On this paper. I didn't work it out yet. I've not worked out this paper. So I've not worked out this paper all this time. Can I believe? So what happens is that John's grandparents started a university fund for him at a bank with $4,000. So he started with $4,000. He says the bank offered 2 options for interest. One, you could go and do $240 interest per annum. So it's a per year thing again, you know. All right. Remember that the number of years trapped behind the figure. This is a A. All right. Remember that the number of years trapped behind the N. So years, the number of years will always be N minus 1. The term number minus 1 is the number of years. All right. Term number minus 1 is the number of years. Pass, right? So it said there are offered 2 options. Option 1 is to pay $240 per year. All right. So the bank offered 2 options for interest. So the interest, after putting the $4,000, you could gain $240 interest every year. So in the first year, you're gonna add this to this after the first year. So year 1 or year 0 when you start, year 0 when you start, the amount in there is 4,000. After 1 year, it gone to 4,240 or 4,000 plus 4,000 plus 240. Year 2, you'd have added this 2 times. So after 2 years, it's 4,000 plus 2 times 240. Remember, I know this is A plus N minus 1D. So this is N minus 1 after 2 years. See that? So this is N minus 1, that 2. The term number minus 1 is 2 times the add in the figure. So that's after 2 years. So the N minus 1, as I said, corresponds to your number of years. And so on, right? All right. The second plan is to option 2 is to increase the interest. The interest will be 5% of the current balance per annum. So the interest is going to be 5% of whatever is in there. That's the interest, 5%. So if you have $4,000 in there at year 0, when you start after year 1, it is now 4,000. But if you're adding a 5% interest, the new figure is that you multiply by 1.05. Understand that? That's a new figure. And after year 2, you have to multiply this again by 1.05. So you get 4,000 times 1.05 squared. And after year 2, again, the year is the number of terms minus 1 because the year does not include when you start. Time has not passed when you start. All right. So, see here now, determine the number of money in the university fund at the beginning of the 9th year. Now, the beginning of the 9th year, it means only 8 years pass now. Done the 9th year yet. So it means that the years equals 8. Now, if the years equals 8, then n minus 1 equals 8. So n equals 9. So that kind of tricky. At the beginning of the 9th year, so you're not the interest for the 9th year, nothing there yet, not calculate. So at the beginning of the 9th year, it means that you have gone 8 years of making payments. So the term number is 9, and is 9. The beginning of the 9th year, you have completed 8 years. So if you completed 8 years, you actually got 9 terms in the series. But the first term is 4,000. So I've gone the 9th term in the series. That's what you have to understand with this thing. You're only at the beginning of the 9th year. So you can't include the 9th year in the calculation. You're at the beginning. So you have completed 8 years. And when you complete 8 years, right, it means that your term number is 8. Your term number is 9. You're at the 9th term. And that's what it is. So your n equals 9. So you're looking for the term number. So the trick you discussed then is this word sum. It said determine the sum of money in the university fund. The money in the university fund, is the principal amount plus the interest. Remember, in this series, you're adding 240 every year. But in this series, you are multiplying. You keep multiplying by a common ratio of 1.05 to the value. So this is actually asked. That's why you know how much is in there by multiplying by 1.05. So even though this says sum here, you're not going to do sum the values. You're not going to sum the values. You're not going to sum the values. Right? Because you want to know what value is in the account. Right? You want to know what value is in the account after that number of times. So remember, say for the AP one, you start out at 4,000, and they keep adding 250. Keep adding. So you really want the sum to 9 terms. So you want T9. What value is it after 9 years? So I've been the 4,000, and you'd have added this, you'd have added 240 8 times, right? So you'd have added 240 8 times. So it will be 8 times 240. At the beginning of the 9th year, you'd have added the 240 8 times, because you'd have added it for 8 years. So you start out with 4,000, and you'd have added this amount 8 times at the beginning of the 9th year. You'd have completed 8 years after you started. 8 years after you started, you'd have added that amount 8 times. So this is a sum of money in there. So you don't use the word sum. Sum of money in the fund. What is the amount of money in the fund? The term. What is the term? Because the money in the fund follows an arithmetic progression. Same thing. The money in the fund follows a geometric progression. That's what it is, you know. You're not adding to the fund per se. The money that is in the fund, the amount that is in the fund, follows a geometric progression. In the second case, the amount of money in the fund follows an arithmetic progression in the first phase. So you're not going to add up the values. So this word sum threw off a lot of people and cause them to be adding values and doing the sum to 8 terms and all of that, and sum to 9 terms, which was not correct. All right, so I'm going to leave this one on the screen. You copy it, take a screenshot of it, and make it bigger. And I just gave you some tips a while ago. So try it, let me see. Can you see it? And hopefully by tomorrow, sleep and wake up and do some solutions on this paper.
Sure, I finished it though before you.
You just finished this a while ago?
Yeah.
Oh, you're working on it. All right, tell me what you get now.
For the first one is 5920, and then for the second one is 5909.82.
Hold on then. Let me think jump off of the thing. Hold on, let me try to send back a link here. Because the thing jump off, hold on, off of the phone. I don't want to drop off. Hold on a sec. Oh, so you don't work it out already. All right then. So I work it out. So you're saying,
Okay.
yes, oh, you get this, you get the 4,000 and you add the amount 8 times, right?
Yes, sir.
You added the 248 times. So you work that out. And then for this one now, you had 4,000 and you have multiplied it by 1.05 8 times. That's all.
Yes, sir.
Right? So that's what you get in. So what's your work out to?
The first one is 5920.
5920. And this one is what?
5909.82.
5909.82.
Yeah. 0.82.
All right, check it. Let me check it. Let us check it. What am I going to check it? Tell me what I'm going to do to check it. Especially the second one. Check it. See if it's right. I'm going to do all of the values and see. It's right still, no? It's right. I believe it is correct. But the second one in particular, let's check and make sure it's right for sure. All right, so year 0. Let's put the year so when you start. Year 1, 2, 3, 4, 5, 6, 7, 8. So start here, so and this is 1 year, 2 year, 3 year, 4 year, 5, 6, 7, 8. You're done 8 years. So you start in the 9th year. But you can't include when you started in the count. So when you start the 9th year, means that you completed 8 years. All right. You have 4,000 years so to begin with. And the total amount that we added 240 years so. Then we add another 240 years so. Then we add another 240 years so. Keep adding 240, 240, 240, 240, 240, 240. Yeah, that's 8 times we added 240. 1, 2, 3, 4, 5, 6, 7, 8. All right, good. For the GP though, it's not an adding thing now. We're taking 1.25 of what is in there. So the amount in there here, so is 4,000 times 1.05. Then now it's gonna be 4,000. All of this figure my times by 1.05 again, so I get 1.05 squared. So that continues, the trend continues. So I'm gonna end up down here. The amount in there is 4,000 times 1.05 to the 8th power. All right, so that is correct. All right, that was kind of just check the actual answer. All right, it is good, it is good. Okay, then, that's it. We do all of them.
Okay.
Bye.
Do them over.
Yeah, do them over. All right, good. All right, good
Thank
night.
you.
Yeah,
Good
man.
night.
Cool. All right, bye-bye.
Mm.